Good morning, everyone. I'm Neil McRae. I'm talking on behalf of Paul Bruce, who runs our wireless research programme up at Astral Park. I'm going to talk a bit about what we found with TV Whitespace and a little bit about where we're headed. I think probably actually of more interest was the previous presentation, because I think from a radio perspective, we know Whitespace will work, and this presentation will cover that very quickly. But what I think we need to get, I think whether Whitespace is going to be successful or not is if we get our act together on making that database a reality or not in some way. I know there's a meeting next week that one of the guys from Nominate mentioned to me about starting to kind of figure that out. So there'll be more trials, but I think the big focus is whether we can make the database work. I'm not going to talk too much about that. It's more on the radio side. So Steve's kind of covered this in some depth earlier on, but in effect, a white space is where there's space in the spectrum where a TV company or where there was once digital TV isn't being used. Interestingly, you find, and here's a slide you may have seen earlier. You may find it has the logo on this one. You may find that where there's challenges in not spots, and I'll talk about what a not spot is in a minute. Where there's challenges in not spot tends to be, as Ben commented, where there's a available spectrum. And from a BT perspective, that's interesting for us because we're trying to get broadband to as many places as we can. Looking at in another presentation I did a couple of years ago, I talked about GFast and some of the challenges in GFast and some of the challenges in technology. And I was trying to do this, I didn't have time, but I was trying to do a slide that shows technology success versus complexity. And it kind of echoes a little bit about what Vince said. The simpler you make it, the more chance of success. I'm slightly worried that the whole database thing makes TV Whitespace a bit of a nightmare and makes it unworkable. And again, I think maybe that's an opportunity as an industry for us to go and say, yeah, we know you want this database, but actually you're just going to make it more difficult for things, or you need to make that database operate in the simplest way it can. And also, what happens when you get some sort of interference? What then? Because that for me, if you're paying for a broadband service and it's because Bob down the road's fired up his remote control helicopter and it's not working, it looks really challenging from that point of view. Just moving on. So not a spot problem. If you think about what the challenges are, so today most connectivity to the internet is provided on a copper network or a cable TV network on coax. In BT we obviously use ADSL and VDSL. And literally the big challenge is line length. Hands up if you've got a long line length. Poor you. Other line lengths are available in other residences. We're rolling out fibre. Actually, last week we hit a milestone. We passed 15 million homes on fibre, which I think is pretty decent by the OpenReach guys. But what we're trying to do is, how can we make that line length issue less of an issue? And there's a couple of ways of doing it. We could build fibre to everyone's doorstep, very expensive, very difficult. We could use radio, which is the subject to this, or there's some other technologies that we're looking at, kind of VDSL regeneration, ADSL regeneration, stuff that allows us to kind of get more out of that local loop. No one, I think, in the world, I think, is more focused on trying to find a way of getting to people's houses than BT. And a huge part of the work we're doing up in Astral Park, and I'm trying to arrange maybe one day that UKNOF goes up there, but a huge part of the work we're doing there is really to figure out how we get as much connectivity to everyone's house. Many of you think we're doing a shit job. Fine. My take is I've seen what the guys in the lab are trying to do. We're running these pilots. We run pilots all over the place, and it really is to try and bring as much broadband to as many people as we can. Why do we want to do that? Well, then we can sell it and we can make money. It's as simple as that. So the more coverage we get, the more money we make on it. And it really is as simple as that. So we're trying to solve the not spot problem. And again, you look at, I made this comment to a customer yesterday, Where you tend to see huge economic benefits is where you have the best telecommunications infrastructure, and where you see the challenge is where you don't. So you look at somewhere like the Middle East where it's very regulated. If it wasn't for the oil, they wouldn't have industry, and there's a lot of investment going into places like Bahrain to try and up the telecoms infrastructure to generate kind of knowledge economies for when the oil runs out. So the benefits of broadband are clear. It enables people to work. It enables people to talk to each other, and it really has a world-changing event for all of us. So here's the kind of lay of the land in a place called Butte, which is in Scotland somewhere. I'm from Scotland, but I actually have no idea where Butte is. But it's far away, and it's kind of rural, and apparently it's beautiful. Other islands are available. The challenge with Butte is really it's a place where the odds are so stacked against you in getting broadband there. It's incredible. You're on an island. There's not very many people there. The distances between people are huge. So it's kind of a really great place to do a trial. So, and there's a few challenges with mountains and valleys and stuff like that. So how do you get line of sight, non-line of sight? Line of sight, in my mind, on radio, it's easy. It's been easy for years. Non-line of sight, I think, is where the big challenge is. So, and then there's the other challenges of deploying it as a workable solution. So, I don't know about you, but when the Sky guy comes round or when the TV aerial guy comes round and he's nailing something to the top of your house, I get slightly worried that something bad's going to happen, like the roof collapses. So how can we maybe reuse some of the existing technology that's there, i.e. a TV aerial that's already there? So that's what we tried to do. We used some spectrum between the kind of 470 to 790 megahertz. The great thing of that is it kind of goes through buildings and it doesn't diffract. And we set up a trial in Scotland with 5 users, and Sutton in Suffolk, which is quite near where our labs are, 14 users. Here's what it looks like. This is in Sutton. So we built this microwave backhaul, and we built a kind of what you would call a hotspot. It's high up to get as much coverage radially as possible. Here's a trialist. Here's a squarial, unfortunately. That kind of effectively delivers the connectivity into a special home hub that we created for the user to drive connectivity through it. It's actually work that's been funded by the government, believe it or not. We're working with the Beeb and other guys to try and come up with the right solution to this. So this trial ran. And the feedback from the users in both locations is pretty staggering. The people in Butte were overwhelmed and actually wanted to kind of start paying for the service almost right away. The same in Sutton. Sutton's a village and again a rural village. Again, backhaul and copper line length really long. Everyone loved the service. They want to start paying for it. So in terms of, is it something that customers will buy? I think it is. I go back to that point about making sure it works all the time. Most of us in this room are used to having broadband all the time and it just works. If we have a situation where white space doesn't work, it will quickly become a non-solution and it will be resigned to the same kind of technology cupboard as ATM and other fantastic technologies like that. So, we really need to all pull together to try and figure out how we make that whole kind of back end of it work. In my mind, that's where the focus now needs to be. One other thing we're looking at, just to cover it, is, and I talked a little bit about this in my last presentation at UKNOF on optical, which is cognitive radio, which is kind of how do we make the radio transmitters actually think a bit more. So in the optical space, we use a really high-powered DSP to kind of tune the light and the receiver and take out the interference. And I think there's some opportunities to do that in this space where we can actually leverage more of the spectrum in a better way and actually push the throughput further. The challenge with it is it makes the price of the devices a little bit more expensive. However, I think if we're able to interface that to the database and interface it, you see here machine-to-machine stuff. If we're able to make that really simple, then the ability to really connect things up in a different way than we're used to really does make a massive difference. Again, I said this before, a lot of car manufacturers have put SIMs in cars, and it's a nightmare to manage SIMs if you have to change them. Ben mentioned that there's other limitations on the cellular network that it isn't everywhere. It doesn't work under tunnels, doesn't work on boats, where this stuff potentially can work in those regions. But we kind of need to think about how we utilise it. We've deployed some cognitive radio on our home hub, so that it tries to tune you to the best frequency, and that works to an extent. But I think Wi-Fi really gives us the focus. Is what we don't want is another Wi-Fi in white space where it's congested and it actually isn't any good to anyone. We're seeing a huge demand for 5 gigahertz Wi-Fi purely because the congestion at 2.4 is unmanageable. I don't know about where you live, but where I open up my laptop, I can see about 50 base stations. And the interference on it's horrific. So whatever we do in TV white space, really in my mind, needs to be focused on making it a credible service that works for those that need it in remote locations. And I think Ben said this. I think he said this earlier, which is the great thing about white space is, and potentially in regions, you might say this is a broadband access region for white space. So we focus the use on there. Whereas if you're on a ship having a party, it's kind of more about actually this is an event sort of use, or it's a flood barrier use, and I think there's a lot of flexibility in it. So that's one of the things that we like about TV white space. I think that the real downside is the amount of vendors that are working on it, which is very few. And if you want to get this to a price point that's acceptable to people to buy, I think there's a lot more work needed on that. And that's why we have to make it successful, because the initial kind of wind-up months where we get volume and the chipset vendors, they recut it, they make it better, they improve it, they get to a volume place where actually the price of it can be £50 to £60 or something like that for a box, then that's when it's really gonna make a big difference. And then your washing machine might have a TV white space transmitter in it, lets you know when the washing's done. We're only going to get to that space if we get the price of these components down, and I think there's quite a bit of time in this. Just one note, so Steve talked about the fact that we've acquired LTE spectrum. In our trial in Sutton, we took the mast down. I'll go back to it. We took the mast down and we actually changed it for an LTE ENO-B and changed the equipment at the users. And again, it worked beautifully. So we're able to, with 2.6, we're still able to generate about 15 meg to the home with an outdoor aerial. That's one of the aspects of LTE that we're looking for. And it really is, as I said at the start, to drive broadband to as many places and many locations at an affordable price for as many people as we can. And that's pretty much the presentation, guys. Any questions? A question here. Come on, Paul.
Am I on?
You are.
I might have missed it. What was the rate to the home on the white space trial, please?
We were getting about 15 meg.
1.5.
Yeah.
Okay, that's cool.
It's not mind-blowingly great, but for people who are used to 256k. It's like a world of difference. You can run Netflix over it, or other TV stations if you so choose. There's a lot you can do with that. I think still a long way to go to get more. But that's where potentially using MIMO, using other techniques that we've deployed elsewhere in the network to increase the bandwidth. There are opportunities there. But again, it goes back to my point about cost of components. And the more Wi-Fi is popular, it's all in our laptops because there's millions of them, and Intel knocked them out for 37p a chip. So if we get it to that price, then we're really rocking.
What was the bad weather trials like on Butte?
There was an impact on weather, but I think the feedback was that it did affect some of the capability, but it didn't knock it out completely. I think, again, this goes back to the how we build it, and the point was made about Archiva and planning permission. You know, one of our biggest challenges in extending broadband is the whole planning regime. It's really difficult, it's painful. It's the second, it's the second biggest hold-up other than power, which is another big challenge. You've got to get power to a location. If you're building a cell tower or a radio tower where there's no power, it starts to become really expensive because you've got to drag the power to that location. So where there's existing stuff is where you kind of home towards. So making sure that there's available space on towers at an affordable price, I think is going to be really important. And if the towers are built well and the antennas on homes are built well, then the weather really shouldn't have a big impact on it. It'd be the same impact that you might get on Sky, where you do get the odd blip when the weather's really bad. But I think, again, those are things that we've dealt with in microwave for years. I think they're manageable.
There's a question off the IRC channel for you, Neil, from
Hooray.
James Harrison.
Okay.
What about the trial scale in terms of users?
Yeah, so I mentioned that earlier on. We had.
And also how speeds are affected by the number of users.
Yeah, so actually the speed per users, we probably haven't done a big enough trial to really understand that. However, if you look at LTE, it's all linked to spectrum. So, and I think we're starting to see the results of what LTE congestion is. If you go to New York, you see a lot of congestion. It will start, as congestion is there, it will start to crank down. I think the bigger barrier to that is probably, at the moment, it's probably actually not on the radio side, it's in the backhaul side. So so getting backhaul to Butte is still a very big challenge. You've got to lay submarine cables. What's there today is actually there isn't any, so we had to use microwave as an example. So the backhaul technology is still going to be a bit of a barrier to this, but I think I think a village like Sutton, if you Google map it, you'll see how big it is. I think it's possible to deploy a service there that would be north of 10 meg for most of the village. I think it's easily achievable. But again, how well we make the radios, how easy it is to install. If it's difficult to install this because you have to put some sort of crane on people's roofs to get the right dish, then that'll have an impact. And what will drive that is how good the electronics are in signal receiver. It's also why cognitive is important, because it will allow us to tune the signal even better. There is a bit on the slides where it talks about, I can't remember off the top of my head, where it talks about the number of users. In Butte it was a handful, 5 users in Butte and 14 plus in Suffolk. And this is, I think the other point is this is probably it's maybe 0.5%, 1% of the population that this would apply to. The other big challenge I think in the not spot is it's about, if you look at the UK, there's probably 10% that have a challenge in location. There is no silver bullet for that 10%. Some of it will be ADSL regeneration, some of it will be fibre, some of it will be radio, some of it might still be satellite even, because there are some places where it doesn't matter what we do, it's just never going to be cost effective or affordable to build to that location.
Yeah, there's another question from the IRC room. How can BT make any kind of reliability or service level guarantee claims to run a commercial service using white space when they cannot guarantee how much white space is available?
And when I talk to my colleagues in research, that is the question I ask them every single day. So that's where the database comes in. I think fixed mobile access, I think we've got a bit of a learning process to go through about understanding how well it works, where it doesn't work, most importantly. But again, I think so Butte's probably a slightly different case. But if I look at what we've done in Sutton, I think it's like running a mobile network. The technology is the same. We have the same tool set. It is absolutely doable. However, if we get congestion in the unlicensed bands, then this will fall apart very quickly. And I think ensuring that we have a way to manage that so that we can give a level of quality is going to be really important. If we don't, this technology, it'll go the way that WiMAX went, sadly.
Okay,
there's a question here.
Is this the technology that BT are proposing to use for BDUK?
So the question was...
Is this the technology that BT are proposing to use to comply with BDUK's 2 megabit semi-universal service obligation?
We are looking at a number of technologies to deploy that. This may be one of them.
Do you share the other technologies?
We're looking at LTE, we're looking at ADSL regeneration, we're looking at VDSL regeneration, we're looking at satellite, we're looking at everything. I mean, you know, we actually have very little, you know, there may be some people, oh, you know, that technology doesn't work. Actually, in this space, anything that works, we're interested in it. And we'll build a lab and we'll fund and we'll invest in it if we think it's going to help us with that solution. We really don't have any kind of religion about is it LTE or is it this or is it that. We want to use as many technologies as we can in an affordable way that gets broadband to as many users as we can. BDUK is one part of it, but actually there's still quite a lot of not spots that aren't in the BDUK space that this would apply to as well.
And will this be on an open access basis in the same way that the OpenReach network is available to multiple players?
I actually have no idea, is the honest question. I think, as the honest answer, so I think in BDUK it has to be. I think legally it has to be, but I'm not entirely sure about that. But you know, BT is a wholesaler. You know, wholesale is a big business for us. Why wouldn't we offer it if other people can buy it? You know, that's my take. Wholesale gives more scale. We need scale in this. Again, you know, as much as I think there's a load of people in the company that would love that BT was the only telco, the reality is we've got to where we are because BT isn't the only telco, right? So having competition is really important. It's important for the government. It's important for users. But I think it has to be, you know, where that will work is where there's real differentiation in the service, and you're not going to get differentiation in the radio part. It'll be the same for everyone.
Okay, Neil, do you want to move on to your next talk?
Yes, sure.